All right. In this lesson, we're going to continue to talk about solving exponential and logarithm inequalities. Okay, this one is from your homework. And we start with the algebraic approach. We're going to factor out e to the power x, right? And make sure you have paper pencil with you. And then we divide both sides by e to the power x. The reason we can do that is because e to the power x is always a positive. Or the other narrative is that you can skip this step entirely because e to the power x is positive. A positive number times an unknown number is negative, then the unknown number has to be negative. Okay, so that's the narrative. So this step is entirely optional. So if you think that a positive number times an unknown number has to be negative, and of course, the unknown number has to be negative. So we ended up solving this inequality. This is a quadratic, of course. And we don't have to do any complete square. It's pretty straightforward. So we subtract 2 on both sides and take square root. So we get x between negative root 2 to positive root 2. So this exercise actually is pretty straightforward. If we look at the function perspective, right? If we look at the function perspective, if you have a device, right? Because graphing this function can be, it can take you some time, even though it can be done. So we have a input and we want to find input, and the function, the rule of the function is such, we want the output to be negative, right? So in order to identify the x-intercept, we set the function equal to 0, right? The output is 0. And of course, we get plus minus root 2, right? Similar steps. And then we know that the number between negative root 2 to positive root 2 are going to be the solution. And from this graph, you can see beneath the x-axis, there's a piece of curve. There's a piece of curve, right? So that's the solution. That's the solution. Okay, so this function perspective could help a lot. And this next one is a logarithm inequality. Okay, so we start with the domain, and we found the domain is between 2 to 9, right? Because we solve x minus 2 greater than 0, we get x is larger than 2. Solving 9 minus x is larger than 0, we add x on both sides, we get x minus 9. Combining these two, we get 2 to 9 exclusive, including not including 2, not including 9. And we got the solution. And the curve, this function, if we graph it, the function should be between 2 and 9. Okay, we'll see that in a minute. Okay, so then we go about to solve this inequality. And we use a product rule, and 1 equals to log 10. So we look at these two, left-hand side, right-hand side, the output are 1 is less than the other, therefore the input is 1 is less than the other, because log function is an increasing function, we use that property. FOIL, right, less than 10, combining like terms, and here we multiply both sides by -1. Multiply both sides by -1. And we got x squared minus 11x plus 12 plus 28 larger than 0. Factor, we get a quadratic inequality again. We found the x-intercepts. Right here, the solution is less than 4 and or larger than 7. Okay, then the question is solved. Function perspective. If we graph this function, you can see, and this horizontal line is y equals to 1. Okay, so this horizontal line is y equals to 1. Okay, and we want it to be less than 1, right? So here we're gonna put 1.25. And we got it. We got the horizontal line, and we want the, okay, that y equals to 1 is kind of, I want to move it a little closer, right? I want it moved a little bit closer for me. Okay, let's see if this will do the job. Okay, y equals 1. So this horizontal line crosses a curve at 2 places. And these 2 points are 4, 7. Okay, 4, 0, 7, 0. Okay, so that's the interpretation, right? So we have a 4, 0, 7, 0, sorry, 4, 1, 7, 1. Okay, because we set it equals to 1. Okay, we set it equals to 1. So that's where the crossing takes place, right? So this is 4, 7, and 4, 1, this is 7, 1. Right here, we set it equals to 1. We set the output equals to 1. Okay. And we get 4, 1, 7, 1. So these 2 points, let me mark it in the picture. Okay. So you can see that all of these ideas, they are, they're pretty similar. They're pretty similar. Okay, they're pretty similar. So let me finish that. So 4, 1, and there's a 7, 1. 7, 1. Right, so we have 7, 1 point. And we're going to just place these marks so you know what things are and learn to read the chart. I'm sure by this time you are pretty good at reading the chart. And we want the curve to be less than 1. So this piece of curve is less than 1 all the way to infinity. And this piece of curve is less than 1 all the way to infinity. So the solutions would be just from 2 to 4 and 7 to 9. So these are the solutions. Okay, let's look at what we got for here. So this solution we got need to be modified because we did not take into consideration the domain, right? So we must. So having a picture here really help a lot because otherwise we almost forgot. So the solution should be, okay, 2 less than, and over here, and this has to be, I'm going to write it as 7. X is larger than 7, and this is going to be less than 9. So it's between 2 to 4, 7 to 9. So we must take into consideration about our domain, right? So let's mark these 2 intervals. Okay, let's mark these 2 intervals. From 2 to 4, right? The red. Okay, and from 7 to 9. 7 to 9, and also circles, right? Circles, we got 4 circles. And there. So these are the solution from 2 to 4, right? This piece of curve to infinity, those are less than 1. And this piece of curve is less than 1, right? You see, this is how we analyze it. So the graph sometimes actually help us to make our answer more complete. If we overlook the interval, which we, if we forget this domain, we just blindly say, oh, the solution is larger, smaller than 4 and greater than 7, then that would not be complete, right? So we have to take into consideration the the function itself, right? So this is the solution. This solution in the graph is a solution to the quadratic inequality. But if we look at the solution to this function less than 1, right? So that solution is really really needs to be, right? So finally the solution, wait, what am I doing? Okay, solution, wait, oh, boldface, never mind. Okay, so the solutions to that inequality, okay, are these. So you can see in this situation, graph actually help us to see better, okay? So that's why it's so important to have the function perspective, okay? Not just only the algebraic aspect. Okay, so let's go back to summarize number 7, right? So first we determine the domain, which is 2 to 9 in exclusive. And then we go about to solve the inequality, right? We use a product. And here we use increasing function. Right, increasing function, if output one is larger than output 2, and excuse me, and input 1 will be larger than input x2. Okay, and for this piece, we solve the inequality. So this entire part is manipulating quadratic inequality. Okay, and we get this picture and we got the solution. But this solution we got here is x less than 4 or x larger than 7. And this is not complete. We have to combine the domain requirement. Okay, the domain requirement is saying domain is between 2 to 9. Okay, domain is between 2 to 9. So we can be less than 4, but we cannot be 2 or smaller. So that's why this piece is, it's bounded by 2 and 4. So that piece is 4 to 2, right? So here it cannot exceed 9 or equal to 9. So on this part, it's going to be between 7 to 9. Okay. So from this example, you can see the algebraic aspect and the graph, the function aspect can be very, very important and very, very important indeed. All right. So let's see if we should do another inequality. Okay. Let's do another inequality. This is going to be exponential. Okay. And this be example number 8. Right? Is this number 8? I think so. 7, 8, right? So once again, we solve for x, right? We can solve for x, and this time we're gonna do an exponential. This one is e to the power 2x plus 5 times e to the power x plus 6. Oops, plus 6 larger than 0. Okay, how shall we do this? Well, if you look at the domain for this function, it's all real numbers. E to the power x is always a positive. This is a positive. So this is a positive for all real numbers. If we understand that, this is positive plus 6 is going to be larger than 6. This whole thing is larger than 6. So larger than 0, of course. So this one, just by looking at this function, you already can tell the solution is all real numbers. All real numbers. Okay, if we are being aware of the range of exponential function e to the power x, that's it. But suppose you don't see that, right? You don't see that right away. Then you may go ahead to do factoring, right? You get e to the power x, whoops, e to the power x plus 2, oops, plus 2, and times e to the power x, e to the power x plus 3, right? And this is a positive. Well, of course, this is both are, this is a positive, this is a positive. Positive times positive is always a positive. And of course, this is always going to be what? Real number solutions, right? So method 1, method 2, you just have to consider, you just have to see it, okay? So next, let's look at the function perspective. If you still don't see that, and you thought, okay, let me just plot the curve, right? I got a tool. So you just plot this curve, and you will see the picture is entirely above x-axis. I guarantee you. Okay. So if I make some adjustments, okay. Oh my God, it's way above, right? Right there, it's way above it. It's way about x-axis. Way about x-axis, okay? You can zoom in and out if you're using a calculator, but one thing is certain, the curve is way above x-axis. Okay, so now I can make the scope just a little bit larger. And it's way above x-axis. This, of course, you want to be on safe side. You want to zoom in and out, change the intervals and so on and so forth. The picture tells us this is above x-axis forever, right? So you're going to draw the same conclusion. Solution is larger than 0. What we're saying here, you can see that if you know the domain and range for these exponential functions, which is very, very powerful, it can totally simplify your life. It can totally simplify your life. I think we have covered most of the methods. Okay, there are 2 more, right? Between 11 and 12, I think I'm going to select 1. Okay, so I'm going to select number 12. I think 12 might be a little complicated. So this is going to be example number 9. Okay, so solve for x again. And in this function, in this inequality, e to the power 2x minus 5 e to the power x, oops, e to the power x plus 6 less than 0. Okay, as we're getting used to plotting the graph, why don't we just do this time earlier? And I think this one is going to cross x-axis somewhere. So there's some part that's beneath. Okay, so let's try that. There you go. So we have a little part that's less than 0. We have a little part less than 0. So let's make some adjustment to see how big, right? To see how big. So we're going to zoom it. So let's do some zooming. And here we can maybe do the 5. And over here to see that picture. Yeah, look at that picture. So we do have a little piece that's negative, right? So we need to identify these 2 points. We need to identify these 2 points. Is it easy to identify those 2 points? It's pretty hard. So we have to use the algebraic method to identify those 2 points. Okay, so we're going to set it equal to 0. The purpose of setting this equal to 0 is that we try to identify the input x such that the function will produce a 0. Okay, so we treat this as a function and we want the function to be negative. We saw this piece, right? So by setting this equal to 0, and this is something we are pretty familiar with, isn't it? I think we did this similar equation before, right? So factor e to the power x minus 2 times e to the power x minus 3, that equals to 0, right? Then e to the power x minus 2 equals 0, or e to the power of x minus 3 equals to 0. And so from the first one, we have 2 here. So x equals to ln 2. And the other one, 4, right? Oops. Let me change the color. And the next one is e to the power x equals to 3. As a result, we got x equals to ln 3. X equals to natural log 3, right? So by this time, because we set the curve equal to 0, we have found the x-intercepts. Okay, x-intercept. We have 2. Okay, so what are these 2 x-intercepts? Because we set the output to be equal to 0. So the first one is ln 2, 0. The next one is ln 3, 0. Okay, so, and which is which? So this point is right here, and that point is right there. Okay, so we're gonna put those points in the graph. Oops. Let me just put those points in place, okay? Plotting these 2 points, because we want the product to be negative, so it should be circle, right? It should be circle. Red circle. Another red circle. Okay, another red circle, and in between. In between, there's a line segment. So the solution is here between ln 2 and ln 3. Okay, this is ln 2, this is ln 3. So the solution would be ln 2 less than x less than ln 3. So that's the function, that's the solution, sorry. That's a solution for this inequality. Okay, the rest of the part, they're all positive. the rest of the part are all, they're all positive. Okay, I think that's all for this lesson. Okay, if you have any other questions, please don't hesitate to reach out to me. Thank you for watching.